So this first example, a rectangular field whose length is 10 meters longer than its width is to be enclosed with exactly 100 meters of fencing material. What are the dimensions? Okay, so we have a rectangle and we have the length and the width, and what we're told is the length is, so I'm going to just say L equals 10 meters longer than its width. Okay, so 10 meters longer, that means it's greater. It's greater by 10, so we're just going to have the width plus 10 will equal the length. And we also are given how much material to enclose the entire rectangular field, which is 100 meters. So we're going to think the perimeter, which is the distance around the rectangle, is what we need to write. So the perimeter of a rectangle is 2 times the length plus 2 times the width. We are given that the perimeter is at most 100, because that's how much fencing we have, 2 times the length. The length in terms of W is W plus 10, and then plus 2 times the width. The width is still in terms of W. And that way we have this linear equation that is only in terms of one variable. And we're going to solve this equation for W. Okay, so to do that, distribute the 2. So we have 2W plus 20, and then plus another 2W, and combine like terms. So 100 equals 4W plus 20. Subtract 20 from each side. That gives us 80 equals 4W, and then lastly, divide by 4. So W is 20. Now, if the width is 20, we also need to know the length, because it says what are the dimensions. So we go back to a familiar expression that we wrote at the beginning of the problem, which is how the length and the width are related. The length is 10 more than the width. So that means the length is 30, or 20 plus 10. And the dimensions are 30 meters by 20 meters. Okay, let's take a look at another example. Jackie either drives or bicycles from home to school. Her average speed when driving is 36 miles per hour, and her average speed when bicycling is 12. If it takes her half an hour less to drive to school than to bicycle, how long does it take her to go to school? And how far is it from school to her home? Okay, there's a lot of information given in this problem, and so for this particular type of problem involving distance, rate, and time, I typically make a table. So I have a distance column, a rate, and a time. And we have 2 modes of transportation. One is driving her car, and the other is biking. Okay, and we don't know how far from home to school that she travels, so we're just not going to fill in any number here. We can put that they are both a distance, and they're both the same distance, so we're just going to put D. We do know the average speed when driving is 36 miles per hour, so that's a rate, and then 12 miles per hour for bicycling. And then it takes her a half an hour less. So we don't know either time, but we know there's a relationship between the times. It takes her half an hour less to drive to school than to bicycle. So if I call her bike time T, then this is half an hour less than that, or T minus a half. Okay, well, we also have a formula relating distance, rate, and time, and that distance is equal to rate times time. So for the first equation, we get D, just kind of go across this first row. D is equal to 36 times t minus a half. And then the second equation, we can form another one using this other row. D is equal to 12 times t. And because we said the distance, no matter which way she gets to school, the distance from her house to the school, if she's taken the same route, is going to be the same, we can set these two expressions equal to one another. So we get 36 times t minus a half is equal to 12t. And we can solve this equation for t. Distribute. On the left, we have 36t minus 18 is equal to 12t. Move the t terms together. And I would do that by just subtracting 36t from both sides. Okay, and now we have negative 18. So negative 18 is equal to negative 24t, and then divide by negative 24. So t is 18 over 24, or 3/4, which is 0.75. Okay, at this point, we just have to go back and ensure we are answering the question. And it says, how long does it take for Jackie to get to school? And we know how long it takes for her to bike or bicycle because that is this t that we solved for. Okay, and that's 3/4 of an hour, 0.75 hours. But the other that you may need to answer is how long does it take to drive? And so that would be 0.75 minus a half using the formula for the time for her driving. And that would be just 0.25 or 1/4 of an hour. But the last thing that we need to do is to figure out what the distance from home is. So you can use either of the formulas that we created involving distance and time. So I'll use the second one. Okay, so that means that distance is equal to 12 times t, or 12 times 0.75, which is 9 miles.